Right. Hi, everyone. So I'm going to change directions a bit. I'm not a visualization person. I work on data analytics, and visualization is an important part of the loop that's involved in data exploration. We're not directly involved with it, and we want to exploit instead what other people are doing, like the speakers that we just enjoyed. So I'm going to talk a bit about tools, and especially innovations in tools that enable rapid access of large data sets very quickly, and a couple of other topics that are relevant to data democracy especially, and a broader suite of applications with social impact. All right, so this is me. I started out life in computer vision and robotics, and that's one of myself in my algorithm. And now I'd call myself perhaps a social data scientist. Anyway, I spent a fair amount of the last decade in industry, about 40%. There's a number of leaves. And it was hands-on. It was actually building recommenders and targeting systems that are running in a number of these organizations. And these days, I work on behavior change, healthcare, education. But those two apparently disparate threads are coming together, and I'm very interested in using data. So if you recall, Cy Sperling is the famous president of Hair Club for Men and also a client. So I'm in that category. I'm a user and a developer of data mining. So a quick observation, data sets for behavioral data, which a lot of people are interested in, are big, but in a certain sense not huge. They're in the terabyte range. All of what those portals have about what people do is roughly on this curve here. There are more extreme volumes of data way off to the right, like all of Facebook, because it has millions of megabyte images. YouTube has, I guess, millions of gigabyte videos. And so those are extraordinary amounts of data. But anyway, I'm going to leave those to the side and focus on this middle range here. And I want to talk about prospecting. I don't like mining. Mining is all about exploitation. And what I like to do is exploration. So prospecting is a process, yes, of eventually exploiting data, but also exploring, discovering, being agile, asking lots of questions rapidly, being able to see what's happening and make hypotheses and try them out. Eventually test perhaps hypotheses at larger scale. But anyway, the exploration is where a lot of the value comes, certainly in industry. Having effective targeting modeling algorithms, it's all about how much you're able to explore and try out. So we developed some new tools. Some of this is a bit technical. We use an interactive language. We actually don't have to write a new language. We write a library and run it in a very efficient interactive language. So it's sort of erases the difference between scripting and programming. We can write code that looks like mathematics because of some features of this language. And importantly, we use both CPU and graphics processor acceleration. And these are two tools that we're developing, and we get enormous leverage from those tools. Another thing we do is we build PCs, but they're unorthodox PCs, which are jammed with disk and graphics processors. There's two dual processors there. What that does is it actually allows us to process data, do an order of magnitude more computation for a given amount of power or a given amount of dollars. Also, we can have about an order of magnitude more storage. We have some recipes for doing things efficiently, which I won't go into. But what I mean at the bottom of the slide by hit rate is that we've examined a number of test problems to see how much we can improve performance. And we're getting two to 4 orders of magnitude for every problem so far. And these include problems from statistics, natural language parsing, behavioral choice models from econometrics, and two of the most common machine learning models used for text analysis and collaborative filtering. So what we're putting together is some more or less conventional tools. You can see there's an algorithm layer at the top. It's interactive. You just talk at this language. There's also a matrix layer, which allows programmers to work at higher level and folds a lot of the complex decisions about clustering, choice of hardware, underneath the logic of an algorithm. So the yellow areas are things that have been developed before separately, as far as we can tell, never used altogether in conjunction. But in addition, we're adding some of these green boxes, which represent pieces of important research. A lot of it's coming at Berkeley, which further accelerate and augment what you can do. And here's some benchmarks that I think are going to be too detailed, but at high level, we're able to exceed, on this one machine, we can exceed the performance of custom clusters with 100 nodes on some important problems, the benchmarks that they themselves use most often. And just another high-level observation about this is that a lot of the work on scaling up and dealing with large data sets is focused on clusters. Unfortunately, when you take an algorithm that runs sequentially, run it on a cluster, inevitably it doesn't run as fast, or the speed up is much less than the number of machines, except in a very few cases when the problem is really a set of independent problems. You may more typically run on 100 machines and have a 10-fold speed up. On the other hand, if you accelerate the performance on each node, the benefit works the other way. It works in your favor in the sense that if you accelerate an algorithm on let's see, an algorithm on 100 nodes and instead run on 10 nodes, which will actually still be faster, your overall computing time decreases by more than 10. So in other words, there's superlinear improvements in overall resource uses when you work instead at accelerating individual nodes rather than the cluster. So a couple of quick things. I'll just keep sketching these things. So we've been working on natural language. Because the kinds of analysis people do on large data sets are very kind of coarse, and we're actually interested in more fine-grained analysis, I suppose more humanistic features of texts. Some of them are listed here. And so we're developing parsers to run. Parsing is the process of assigning a grammatical structure to a sentence. And it's extremely slow. So we're able to get nice acceleration on this problem and, in fact, show that this problem, which doesn't look like a good match for graphics processors, is, in a sense, a perfect problem for graphics processors. They run as fast as they can possibly run. All right, so I'll skip over that one. And part of this, we're trying to develop a theory, a computational theory, I should say, of stories. All right, so I'll skip over this. One interesting experiment that we're doing is patterned on what's called a Wechsler logical memory test, which is basically a test of someone being told a story and then, after a pause, being asked to recount the story. And what that does is it allows you to examine in detail how stories get transformed in the retelling. So we're doing a mechanical Turk version of that. So it's essentially the telephone game. And it helps you develop measures of how stories might be changing over time. So we can see stories unfolding in social media and other venues. But we often don't really know where they're coming from unless they look exactly like each other. So all right, well, technical ideas. Anyway, all right, so we're trying to take these low-level tools and stretch them up into things like story analysis. Another important area is causal analysis of life events. This is just a couple of slides. So there's a remarkable social media site called LiveJournal, which people keep their journals. And they post life events. We're using a life event inventory from psychology. And the idea is to recognize some of these using simple featureizations and then look for causal relationships. This is a special kind of analysis that tries to untangle all of the potential confounding effects, because obviously a lot of these things interact with each other. And but the more we can observe, the better chance we have to actually sort of tease apart which are the direct relationships from the indirect ones. Okay, and then we want to take this sort of combining with the last idea, look at narrative structures as well in people's life stories. The way they talk about themselves obviously well, I think it's obvious, has a strong effect on how they deal with crises or challenges in their lives. We like to try to recognize some of those patterns and understand their implications for people's outcomes. And, all right, there's some methods. All right, so very quickly, again, the idea is that we're developing fast tools that run on a desktop that support rapid exploration of pretty large data sets in the terabyte range. So all of what a lot of portals have, most of what Twitter has, most of what Spinner produces, perhaps all of it, and then use richer tools for analyzing both language and causal effects of life events. Okay. All right.